Chabatot. I think you might have heard an announcement that the recording is started. So my name is Chabatot. I am lead of the Google Developer Group Fresno and the Women Tech Maker Fresno meetups. This is a joint meetup. It's the second in a series of 3 meetups about Android 11. And today we're going to talk about privacy. Just a second. I'm arranging my presentation. So privacy, it's an area where Google is evolving over the last several releases of Android, and they are continue to evolve past Android 11 even. And let's see main areas we will go into detail today. Android 10 changed the paved path for the platform to bring even greater protection for users' data. And Android 11 makes further changes or introduces even more. First, we're going to talk about one-time permissions. So when we give a choice, users are choosing to share less private data with their apps. We also saw that there are many apps which request background location access with no need for it. So Google asked the users about what other types of data are important to them. Based on the feedback in Android 11, Google is bringing users more granular control over users' private data, like location, camera, microphone, and significantly limiting access to background location. Users will be able to grant temporary one-time permission for location permission requests. Also for microphone access. Suppose this is a conferencing app that is rarely used. Users can make voice calls. They have the option to not permanently commit to the record audio permission. Similar principle applies for camera access. If the same app also supports video calls, the app would request record video permission. So once again, what is new here is this one, only this time. The while using the app is already a recent enhancement, but the one only this time even gives a finer grain control. Now, as a developer, you may have this important question in mind: what do I need to change? And the good news is nothing, in case you are already following the best practices. Let's talk about these best practices. What you see here is a pseudocode which basically applies for all permission checks and grants. Let's say the user clicks on this location button. Then first we check if the permission is already granted. When the code first runs, it's not granted. Next, we let the system decide if any rationale is needed to be displayed for the user, for example, in a in-context UI explanation. And this is very important, by the way, to explain to the user why you need that permission. And it can help a lot with your software to not be denied if that's important. Normally, not always, the first time the system will consider that the rationale might not be needed. Now, once we are past these checks, the actual permission request can occur. This prompts the user with the dialog we saw already, so including this only this time choice. Let's say the user pressed deny. In such case, we have the on request permission result callback that's going to be invoked. The permission in this case was reject. So we should make sure to explain which functionality won't work because of this decision. For example, you can display a snack bar to the user, which functionality will be not available because of that. Now, location permission is a little special. To give users fine-grained control in Android 10, Google splitted permissions between foreground and background location access. Apps are encouraged to incrementally request these permissions to give users better control. So first, you always have to request the foreground permissions. This can be coarse or fine location. And then you can move on to the all the time location access in the background. In Android 11, this pattern is mandatory. It's a requirement. There is no change to the foreground access request. This example will be adequate for most use cases. And in pre-Android 10, the background access is implied. So 10 splitted it. And now with the 11, there are mandatory workflow we have to adhere. You can see here on the top right again that what we show here is applying to Android R or Android 11 API level. So as I mentioned, incrementally, we request first the foreground, and then we can request the background access. And also this page, just as with the deny, has a limit. So the deny has a two-strike policy, which I think we are not speaking about in this slide deck. But that's also a great policy that once you denied something 2 times, it will consider it, it won't bother you again with it. Now, if you are not at Android API level R, but you are with earlier 29 API level or lower, Google has to ensure somehow the compatibility. So it is still allowed to request both foreground and background at the same time as in the past, and in this case, this type of dialog will be shown. What you see here on the screen. And yeah, let's move on. So, oh, this is great. I love that, because you might have hundreds of applications installed. Who knows when and why did you grant access to different apps? You have some applications which you use very frequently, but there are some which just lay around and you seldom use them, but that's very important at the time. So if you haven't used an application for several months, their permissions will be reset automatically. And I think that's great. It gives you a peace of mind that nothing's gonna do anything in the background or sneakily. It's gonna be denied. And so from developer perspective, if you already follow best practices, this won't be a problem for you. The user will be again presented with the choice dialog. Everything will go smoothly. This only affects apps with the target API level of 11 or up, or in the future. But I think this is great from privacy perspective. So let's talk about some background permissions. Most apps don't need this, but there are certain cases, what you can see here. where the user expects the app to primarily work in the background. You are syncing your data in the background, connecting to other devices, casting to your Chromecast, whatever. The app can consider redirecting the user to app details settings screen to toggle auto reset for the app. And now let's talk about this is new, support for apps to discover potentially unintended access to private data. A best practice for building mobile apps is to ensure transparency for accessing private data. For example, it should be clear and obvious to the user why a voice over IP app needs access to their contact information. So what are the challenges faced by developers in identifying data access in their code? First, large apps often have some orphaned code and they have large teams. Accidental data accesses can happen. Any apps may use closed source third-party SDKs. These libraries might access private data without knowledge of the developer by piggybacking on top of already granted private data access. In above cases, these access patterns may or may not be intended, and it is not always easy to identify. So in Android 11, the system provides 2 new APIs to bring developers back in control over their app's data usage. The basic feature is a callback when data is accessed. On top of that, Google allows the developer to attribute access to logical features within the app. In this picture, each blue line represents a piece of code in the app, and the gray lines symbolizes that this code accesses certain private data. When an app calls an API that returns private data, the system calls into a collection handler immediately before returning to the calling code. Hence, at this time, the collection handler can collect the complete stack trace to record which code performed the access. So let's look at the API. This shows how to set up a callback for data access through the AppOps Manager class. You can see that this is Kotlin code. Kotlin is now the first-class citizen. If you want to, but obviously you can do this in Java as well. If you want to consistently track it for the entire app, you can set it up within the application onCreate. Say you want to localize it to a particular part of your app, you could do it within the activity onCreate. Within the onOpNoted callback class, your app will be notified of if data access, in case of a data access in a synchronous call. When this happens, you may log the stack trace to help you identify the source of this access. In case of asynchronous accesses, for example, when your app registers a callback listener. Check out the API reference for more detail. More complex apps often contain multiple distinct features. For example, a mapping app might have a navigation part, explore nearby shopping, find friends. So in Android 11, that's why Google allow for an app to attribute a subset of the app as belonging to one feature. Now, each of these features uses a subset of private data. For example, Find Friends feature might not need to use the microphone. Having features as a higher-level concept compared to just areas of code makes it easier to find what feature have accidental data accesses. Further, this will make it easier to explain to the user what private data is used for. Data Auditing API allows you to attribute the data access to features. So let's see how we can do this. To attribute the feature in your code, create an attribution context and give it a meaningful name, what corresponds to your feature, for example, find friends in this case. Then you can pass this context to the API calls. And then within the auditing callback, you can recover the attribute through this variable attribution tag. Then you can, for example, track the attribute with your analytics solution and associate particular feature with private data access. To provide better accountability for apps to access private data in the foreground service, Google added a couple of new foreground service type values, microphone and camera. So now we are moving on to another larger topic. Android 10 introduced the concept of foreground service types. Apps can declare their intention to access this info with its foreground service. Only two types were enforced. Media projection, auto, Bluetooth, TV, or other device connection, monitoring, interaction, and location like GPS, map, navigation, location update. There are a few other defined types. And so we want to enforce the accountability for these accesses. There's a couple of new additional foreground service types in Android 11. Camera is one of them. Since Android 9, apps can no longer access camera in the background. So for quite some time, this can only be done in the foreground. That's great. So it's not gonna sneakily spy on you. If your app targets Android 11, it additionally needs to declare the new types, as the foreground service can't receive the data. You can see here this manifest snippet. Here's the foreground service type keyword. You have to declare it. And sorry, I already showed this manifest. And you can also combine multiple foreground service types there. For example, here you also need the microphone. To recap, on Android 11, if you need to use foreground service to access any of these data, you must declare to corresponding foreground service type in the manifest. This is going to provide greater transparency toward the user. Now, let's talk about changes to package visibility. On Android 10 and older, this API, the package manager, and others allow an app to see which other apps are installed on this device, like any. And I think that can be a privacy problem, like why any app can know what other apps I have installed, right? So with Android R, to provide better accountability for access to install apps on a device, Android 11 includes some changes to how apps can query and interact with other apps. For several common scenarios, you don't need to make any changes. Let's look at these scenarios. Query. In case of this query, just a second. In case of query and interaction, no change requires, but in the most cases, we'll talk about later on. So if you target Android 11, this API will return package info for your own app as expected. So no unaffected scenario again. The get installed packages 0 will return only the calling app, certain system packages such as the media provider and some other which implement core Android functionality. So no changes required. If you send an implicit intent for another app to take action, for example, use the image capture intent to take picture using the pre-installed camera app, yet again, no changes needed. As expected, if there is more than one eligible app, the system will show the dialog box for the user to choose from. For example, if another app calls your app's content provider and expects results, that's also an unaffected scenario. Without making changes, your app can query and interact with those apps. Besides these scenarios we just discussed, by default, your app will return name not found exception, regardless of whether this com.another app is installed. So let's go through a few scenarios, how to handle them. If you need to explicitly interact with another app, for example, invoke a specific activity, bind to a service, use the new queries element in the manifest to explicitly specify the packages your app needs to query or interact with. The app can now query for com.example.store, start, bind to its services, etc. Multiple package entries are permitted, as you can see in this little manifest snippet. So this is a new Android 11 feature. Or you can do this implicitly through an intent filter signature. The app can now query for all apps that handle an action send intent for JPEG images in this example to populate custom share sheets. These apps will now show up in get installed packages results. In practice, Google found that most apps can easily express necessary package interactions with these new intent and package queries declarations. Let Google Developer Relations know what use cases of your apps may require query all packages. They are interested to discover these use cases. They are waiting for feedback on such. Sometimes, if a social map or point of interest app fires a view intent with certain URL, you want to be able to take users directly to a default native app that can handle the URL. If you did this, your users will get a disambiguation dialog box. That can make the user experience janky. So on Android 11, there's a couple of new intent flags, one of which is flag activity require non-browser. It ensures that the intent is only handled by a default native app. If one isn't available, this will result in an activity not found exception. In the exception handler, you can choose to take over handling the intent. For example, display the URL in a Chrome tab web view within your app. There's another similar intent flag called flag activity require default. It ensures that there must be one default app that can handle the view intent, else it also returns in the same exception, so you can override the experience for the user. Here, we are showing how you can test package visibility. ADB is the common debugger tool for Android. And with this command, you are starting package manager log visibility command. And then you can see an example output when something was blocked. Let's move on to another bigger topic, which is scoped storage. Before the introduction of scoped storage in Android 10, there were two classifications of external storage, the app storage and the shared storage. Any apps with storage permission had access to all shared files. Android 10's scope storage changed this, adding a distinct distinction between media files and other documents. Rather than apps gaining access to all files in shared storage, they would now only have access to media files. In order to gain access to documents which could potentially contain more sensitive data, the app needs to ask the user to grant access specifically to those documents. Here are the specific scope storage changes in Android 10. Google received lots of feedback from developers. Thanks for that. Developers told that they need more time to migrate. Google responded to that by supporting a temporary opt-out via a request legacy external storage manifest attribute. So Google understands if your app is large and you need more time to accommodate these scope storage changes. So this is even, some people are struggling, some developers struggling, might be struggling with Android 10. Android 11, as we will see, has even more changes. So let's move on to Android 11. Android 11 improves upon scope storage in a number of ways. Let's see. First, Google made further adjustment to storage permissions. Storage renamed to files media, and we will talk about these write external storage and write media storage flags. Android 10 required user to consent to edit or delete media not contributed by your app. To do this, you must use the Media Store API to trigger a dialog to request user consent. If the user accepts, you will get a callback into your app, and you can proceed to access the file, either with the Media Store APIs or with the file path. In Android 11, Google is improving the user consent flow for editing or deleting media. So now you can batch multiple edit or delete requests in one dialog rather than pop one dialog per request. This should significantly improve the user experience in your app and was a popular request from the developers in 10. So Google is very thrilled to deliver this. Here's a code sample for the bulk edit access example. I will share, by the way, later on meetup.com my slide deck, so you can get that. Don't worry about screenshots. And so you can see that first the URLs of the files need to be deleted and edited is gathered into a list, and then here's this create write request call, and then once the start intent sender for result invoked, that's when you won't be asked for each separate. In this case, there are, it seems like 8 files. You won't be asked 8 times, but only 1 time, which is great. So then later, you can see if the user denied or allowed the permission for addition or deletion. Let's move on with the file access changes. So with the action open document tree, the user can no longer access the following folders and files from the documents UI. Root of internal storage volume, SD card volume, downloads directory, the Android/data directory and all subdirectories, and the Android/OBB directory and all subdirectories. With the action open document, intent action to request that the user select individual files from the following directories: Android/data and the Android/OBB directory, and those subdirectories won't be allowed. Those are more system type files. Google's general guidance for accessing media files is through Media Store, because that lets the system better manage file access and it is more performant. More on that later. So in Android 10, direct file path access was locked down. However, many developers told Google that this isn't always possible, which Google understood. And like, for example, this is important for apps using third-party libraries like FFmpeg. In response, Google re-enabling this in Android 11. Direct file path access for media provides a native file-like interface to the media store to allow apps and libraries to continue using file APIs to access media content. If this is something your app needs, the recommended approach is to opt out of the scoped storage with the manifest flag on Android 10. That will give your app a uniform way of dealing with file paths across different versions. Performance impacts. Now, these are the best practices. Keep in mind that the API that supports native file access is built on top of Media Store, and it's primarily intended for apps and libraries that rely heavily on these APIs. Because it's built on Media Store, there can be some performance penalties using it. If performance is your number one priority, use Media Store APIs. Based on Google's tests, it is expensive for opens and first reads. Obviously, the more your app uses it, the bigger impact you will see. Now, talk about a little bit special app access. Google wants to continue allowing some apps to have broad access to files on external storage, provided they have a use case that truly requires it. In Android 11, these apps can declare manage external storage, which will allow them to request the user to grant them all file access in the settings. There are a couple of apps examples that will be allowed. File managers apps, these are apps whose main purpose is to let the user manage files, backup or restore, apps that require bulk access to files. However, if your app requires access to a single file, such as a word processor app, you should instead use the storage access framework. Look for Google Play to provide guidelines for apps that need this permission. Before Google broadly roll out this policy change in Google Play, we would love to get your feedback on your app's specific needs in this area. Sorry, I heard a jingle. I'm just checking if anybody wants to join. It seems like no. Okay, I didn't have time to read the chats, so I'm gonna get back after the presentation. If you have any questions, you can unmute yourself and ask anytime. Sorry, I haven't told that. Let's talk about other important changes. Before Android 11, the read phone state permission covers a broad set of information, including general states such as if the phone is ringing or idle, or more private information such as phone numbers. If your app targets Android R, the permissions become more fine-grained. Read phone numbers permission covers these APIs, like telephony manager get line 1 number or telecom manager get line 1 number. Another fine-grained form permission, sorry, not another, you can see here example Android manifest. If your app only needs phone numbers, you may want to declare your permissions like this here. You just need to request the read phone state permission up to API level 29. Above that, you would need to request the read phone numbers permission instead. And so this example shows how you can distinguish between the SDK versions. A little bit about MAC address. So MAC address, this is not Android specific, but generic networking specific thing. Every network interface has this MAC address. And that's such an identifying information that it's unique for every single produced network card. That's a unique thing. So it can pretty much identify you if somebody gets to know your MAC address. Therefore, I guess that's the reason why in Android 11 you can no longer access simply the MAC addresses. And you can only list IP address and other restrictions you can see here, like with bind. There are some restrictions. These are all in the name of privacy. There's also some restriction regarding system alert windows. The preloaded apps still are granted the permission by default, by the way. So yeah, this is another change to keep in mind. So to wrap it up, you could see that in several places Android improved or introduced new features, so like more fine-grained permission by just granting it one time, data auditing API callbacks, and so on. And Google is putting emphasis on privacy for Android generations now, and I'm pretty sure this is going to continue. And they are also always keen on getting your input. If you have any Android application and struggling with something, the developer relations people, I'm pretty sure, happy to take your input. So I think with that, I arrived to the end of my presentation. And I want to thank you for listening. Let me know if you have any questions, and we're gonna start the raffle soon. I'm gonna read now, read the chat right now. Yeah, so I read Flutter and asks, does the MAC address restriction includes all connectivity technologies, Wi-Fi, Bluetooth? I'm not 100% sure. I have a feeling that yes, but I would need to read about that. For app data, what could be the best way to avoid other apps access my app data? Well, one way to avoid that, there are several ways. So if you target Android R, and if you, here's a drastic way, if your app is going to work only on Android R and above, that's going to give you some kind of protection, because Android R is start to enforce these new rules. For a while, if you are not limiting your app to work only on Android R or above, you still have the danger that some apps might be able to access your data. So first of all, if you are not placing any files into the shared storage, if it's just configuration settings or something like that, it's not as easy for other apps like they have to go into great length to access those settings or data which is really bundled or close to your app. Once your app is, for example, recording photos, that's not in the class of those settings data and or not just settings data, but settings can even be in small databases like SQLite or so there are some small databases for these purposes. But if you are saving images, voice recording, or PDF files, those gonna go to places which might be able to accessible to other software. In that case, you might be able to devise some encryption. Yet again, you always have to keep in mind that encryption might be crackable. So because if your app is able to read that data, then your app contains the encryption keys. And if those are very valuable data, somebody might be able to disassemble your code and get those keys. But in simpler cases, then you might just want to do a transparent encryption decryption scheme. Then other applications won't be able to right away see what is it. So I haven't had this problem yet on my own, so I don't have that much experience with that, but I would need to yet again read about this problem. So the main message is that it's gonna improve with the newer versions of Android. Now we know that the Android ecosystem is fragmented, so some people might only have Android 8, 9, but eventually from statistics, it seems like that people are catching up sooner now with newer Android versions, partially because the newer Android versions make it easier for the manufacturers to upgrade from Android versions to versions. So in the future, I expect that the manufacturers will be able to provide you newer out of on-the-air updates. And so let's just hope that Google will keep doing this, and the general security and privacy will enhance this way. I don't know how much this answered your question. So I think, all right, I will stop the recording and move on towards the raffle.